Alright guys, so this is the first video from 3.1b. So this deals with example 1 and 2. Something to make note of, anytime you see the words maximum or minimum or maximizing profit, minimizing cost, that is your clue that you are finding something to do with the vertex. Because if you think to my parabolas, here is my minimum value, which would be minimizing cost, or here is my maximum value, which would be maximizing efficiency, maximizing number of workers, whatever the case may be. Both of those are happening at the vertex. So here's my first example. It says that the total revenue for Fred's Estate LLC is given by this function, where X is the total number of apartments booked. So that matters what X means. What number of apartments booked produces the maximum revenue? Okay, so I have a function, R of X, and I want to know how many apartments do I need in order to maximize my profit? What any good business should be asking. So, X is the number of apartments, which is what I'm maximizing. So I'm going to take this function, and I'm going to find the vertex of it. And I'm going to go ahead and rewrite the order so it looks like standard form that we are used to. So I've got standard form. I need to find my vertex, which is negative b over 2a. I have negative 400 over 2 times a. Well, that gives me negative 1 on the bottom, which is 400. Now, normally I would take that value and plug it in. If I do that, I'm going to get out the y value, or the revenue. So 400 is the number of apartments, because remember, this is the x value, and they asked me for what was the number of apartments booked that would maximize, which they told me was x. So actually here is my answer. 400 apartments would maximize my revenue. I don't need to plug that 400 into the function, because then that gives me out the actual revenue amount, the however much money I'm going to make. Okay? So the second example says, a rancher has 400 feet of fencing to put around a rectangular field, and then he wants to subdivide the field into 3 identical smaller rectangular plots by placing 2 fences parallel to one of the field's shorter sides. So first, let's just figure out what that means. So I have 400 feet of fencing. Now fencing goes around the perimeter. And I don't just want to go all the way around, but I also want to create some smaller fields for whatever reason. And they're saying I want it to be parallel to the shorter side. So here is where I'm creating my other fences. Now theoretically all 3 of those should be exactly the same, but it's not drawn to scale. So there's my kind of diagram, my rectangular plot, and then I drew fences down the middle to divide that thing into now 3 separate spots. Okay, so that's what that first sentence says. Now, second sentence, find the dimensions that maximize the enclosed area. And as soon as I hear that word maximize, I'm thinking, okay, I need to find a formula so I can find the vertex. So find the dimensions that maximize the enclosed area. Write your answer as fraction reduced to lowest terms. So the first thing I have to do is get some x's and y's set up. So I'm going to say that x is the width and y is the length. Okay? So that means that's x, because that is my width, and this is y, because that's my length. Now, because these are all rectangles, that means the top is y, because rectangle opposite sides are congruent. This other side is x, and all of these little pieces in the middle are also x. Okay? So there's my variables all set up. Now, I need to still get an equation down. So I'm thinking, okay, I'm laying fencing out. Well, fencing goes around the perimeter. So I'm going to draw fencing here, and that's y, length y. I'm going to draw fencing here, that's plus an x. Fencing here, which is plus y. Fencing down the side, x. And then he also wanted to do fencing on those parallel pieces because I want to divide all this up. So there's plus another x, plus another x. Okay, so that is my fencing. That's where all the fencing is going. Now they told me in the problem that I had 400 feet of fencing. So that fencing has to be equal to 400. Now on the right hand side I'm going to combine up like terms. I have 2y's, which give me 2y, and I have 3x's, which give me 3x. So there's my first formula, and that is just the perimeter of all of my fencing. Now I want to talk about, okay, well, what am I actually maximizing? So if we go back to the question, it says find the dimensions that maximize the enclosed area. I want to maximize this in here. So I need an area formula. So the area of that thing will be length times width, which we said the length was y and the width was x. Now you can write it as xy, same thing. I have two variables and two equations. So if you think back to your substitution, I want to take this perimeter thing, solve for one variable, and then plug it in over there to the actual equation that I'm finding the vertex of. Because remember, this, the one on the left, is the one I'm maximizing. So that's the one I need to find the vertex of, not the perimeter on the right. So over here, I'm going to solve for y. So minus 3x to both sides. And then divide by 2. So y is 400 minus 3x divided by 2. I'm going to take that y and plug it in where I see this y. So I'm replacing y with 400 minus 3x all divided by 2 times x. And that is what I'm finding the vertex of. So you can handle this several different ways. That is x over 1. So what I would do is I'm going to distribute, well, first let's write it like this. I'm going to multiply across the top. So that's multiply across the top, 400 minus 3x times x. That's what I wrote in the second line. On the bottom, 2 times 1, which will give me a 2. Now I'm going to go through and distribute that x. So I have 400x minus 3x squared all over 2. Now I'm going to split up that 2. 400x divided by 2 minus 3 over 2x squared. Well, reduce 400 divided by 2 gives me 200x, and then that 3 over 2 is just going to be written out front. So now I have a function that I can find the vertex of. So I'm going to rewrite the order because I like it to be written in nice standard form. Now I'm going to find the vertex of that thing. So negative b over 2a, it's going to be negative 200 over 2 times a, negative 3 over 2. So do the bottom first. You can either do it in your calculator or do it in your head. 2 times negative 3 over 2 is going to give me negative 3 divided by negative 200. 200 divided by 3 doesn't go in evenly, so you can write it as a decimal, which will give me 66.66666. So I'm just going to say 667, round to 3 decimals. Now remember, x is the width, so go all the way back to the top. X is the width. They want me to tell them the dimensions, not just x, but x and y. So I'm going to take this 66, and I'm going to fill it in for my equation. So that will happen over here, right there, because that's where I can get y. So I'm going to have y equals 400 minus 3x all over 2. Um, 66.667 all over 2. Put all that in your calculator, and that will give me 99.999, which will round up to 100. So my dimensions are, we're going to say 66.7 by 100. Now you can write 66.6 as either an improper fraction or a decimal. With the real world problems, I'm good with decimals.